Hello everyone and welcome back to our videos. Today we will talk about the oxygen systems and their components. Actual servicing or repair of the oxygen system itself must be accomplished in accordance with manufacturer instruction. Gases oxygen systems. Gases oxygen systems consist of tanks. The oxygen is stored in regulators to reduce the pressure to the relatively low pressure required for breathing, plumbing to connect the system components, and the last one, masks to deliver the oxygen to the crew member or passenger. And we will today talk about the tanks and the regulators. The first component we will talk about is the tanks or storage cylinders. Most military aircraft use a low pressure, approximately 450 psi, in large yellow painted steel cylinder. But today almost all gases oxygen is stored in green painted high pressure steel cylinders under a pressure of between 1800 and 2400. Cylinders must be hydrostatically tested to 5/3 of their working pressure and stamped with the date of the test. All oxygen cylinders must be stamped near the filler neck with the approval number, the date of manufacture, the dates of all of the hydrostatic tests as we talked before. It is extremely important before servicing any oxygen system that all cylinders are proper for the installation. They have been inspected within the appropriate time period. The cylinders for either type of system must meet the same requirements and should be painted green and identified with the words AVIATOR'S BREATHing OXYGEN written in white letters on the cylinder. Large aircraft normally have some type of thermal relief system to vent oxygen to the atmosphere if the cylinder pressure becomes too high. To alert the crew that a thermal discharge has occurred, many systems use blowout disc as a thermal discharge indicator. The second component are regulators. There are two basic types of regulators in use. The first one, low demand system, and the second one, a continuous flow regulator. The emergency oxygen systems that drop masks to the passengers of large jet transport aircraft in the event of cabin depressurization are of the continuous flow type. Continuous flow regulators are either the manual or automatic. The manual continuous flow regulator typically consists of two gauges and an adjustment knob. A right gauge shows the pressure in the system. As we see here, this is the right gauge. And the other gauge is a flow indicator and is adjusted by the knob in the lower center of the regulator. And this the gauge and this the knob who will regulate the flow. The second type are the automatic continuous flow regulators. Have a barometric control valve that automatically adjusts the oxygen flow to correspond with the altitude. As we see in this figure, this the second type, the automatic continuous flow regulator. And here we have just one indicator because we have a barometric control valve that will automatically adjust the oxygen flow as we talked. So this gauge will show us the amount of oxygen inside the cylinder. Oxygen is usually supplied to the flight crew of an aircraft by an efficient system that uses one of several demand type regulators. Demand regulators allow a flow of oxygen only when the user is inhaling. This type regulator is much more efficient than the continuous flow type. We have two types of demand regulators, and the first one, called regulator demand regulators, are used by the flight crews on most commercial jet aircraft. When the supply lever is turned on, oxygen can flow from the supply into the regulator. The second type is the pressure demand regulators, and this type operate in much the same way as regulator demand regulators, except at extremely high altitudes where the oxygen is forced into the mask under a positive pressure.